At this point, we have covered 4 different methods for factoring, and so we're going to kind of pull them together here and look at our factoring outline, which basically says for any problem where the instructions say to factor, especially if they don't specify what method of factoring to use, this is kind of the outline or the process you're going to follow. So the first thing that you'll notice is number 1 says always factor out a GCF. So no matter what, we always look for that first, and you should always factor that out first. So oftentimes that'll be the first step in a multi-step factoring problem. So we'll factor out the GCF, write what's left in parentheses, and then often what's left in parentheses will actually factor further using another method. So then either if it doesn't have a GCF or if you've factored out that GCF and you're looking at what's left, then you're going to determine what method of factoring you're going to use based on how many terms the polynomial has. So if it is a binomial, meaning that it has 2 terms, the only method that we cover in Math 112 is the difference of 2 squares. So that's what you're going to look for. So if it has 2 terms, then you're going to look, is it a difference, and is the thing that are the things that are being subtracted 2 squares, right? 2 things that have been multiplied by the same thing to get that answer. And remember that there's no such thing as a sum of 2 squares, right? So if you see a sum, meaning a plus sign with your binomial, you know right away it does not factor. Okay, so then if it has 2 terms, that's the only one we're going to check in Math 112 is difference of 2 squares. But if it has 3 terms, meaning it's a trinomial, then we're going to use the AC method. And then if it has 4 terms, that's where we will use the grouping method. So basically GCF first, and then you look and see, does what I have left have 2 terms, 3 terms, or 4 terms? And then I'm going to choose my factoring method based on that. And then this is like that old Brian McKnight song that says, repeat steps 1 through 3, right? So we're going to repeat steps 1 and 2 here. So once you've done a factoring step and you have it factored, you need to go back through these steps, check and see all the things that you have now that whether you factored them or not, do they factor again? Do they factor further? And you basically are not finished with your factoring problem until you can look at every single factor, right? Every single thing that's being multiplied and say, that doesn't factor further, that doesn't factor further, that doesn't factor further for every single thing listed. And then remember, you can always check your work, and it's worth doing that, especially on a test, just to make sure that you are indeed getting back to what you started with. So let's follow this process with 2 examples. So the first one here we have is 2x squared minus 72. And so step number 1 says to always check for a GCF first. So that's what I'm going to do here. I'm going to look for, is there anything in common between these, in this case, 2 terms? And yes, there is. So I would go ahead and I would factor out, in this case, a 2. And then in parentheses, I'm going to write what's left when I divide by that GCF. 2x squared divided by 2 would just be x squared. And then negative 72 divided by 2 would be negative 36. All right, so that's my first factoring step done, which is a GCF. And so then I need to keep going, right? I need to see, does this factor further, or does any part of this factor again? So I've got, this is a monomial, just 1 term. A monomial is not going to factor, so we can basically kind of ignore this 2. If we do factor again, you just need to make sure you bring that down. So the analogy I always use is I say that's kind of like the kid brother that your mom makes you take along on your date. You shove them in the back seat and try and forget about them, but you can't just leave them behind, right? So you have to bring it along on each step. All right, so then if we look at the part in parentheses, this factor, we can see, does this one factor again? So how would I determine what method to use? I would look at how many terms I have. In this case, there's 2 terms. This is a binomial. So I've got x squared and I've got negative 36. So if it's going to factor, it's only going to factor if it's a difference of 2 squares. Now, is this a difference? Yes, because there's subtraction. are the two things that I'm subtracting squares? And in this case, yes, they are, right? So I know x squared would give me x squared, and then 6 squared would give me 36. So that means that this part in parentheses is going to factor as a difference of two squares. So the way I do that is two sets of parentheses. X times x would give me x squared. 6 times 6 would give me 36. And every time we factor a difference of two squares, one of the parentheses has a plus and the other has a minus. But then that basically took this part, and that part became x plus 6x minus 6, but don't forget kid brother, right? Don't forget to bring down the 2. And then I need to check this again, right? So I need to check every piece of this, every factor, and see will it factor further. So again, 2 is a monomial, that's not going to factor. So then let's look at x plus 6. So that is a binomial, it has two terms, which means if it's going to factor, it's going to be a difference of two squares. And right away I can see it's not a difference, it's a sum, right? It has an addition sign. So that means that this part is not going to factor further, right? Which means if anything else factors, I would just bring it down, right? So I would just bring down anything that doesn't factor. All right, and then this part, the x minus 6. So again, that's a binomial. So binomial, at least in Math 112, is only going to factor if it's a difference of two squares. Now this one is a difference because it is a subtraction. But if I look at the two things being subtracted, I can see they're not squares, right? So like there's not a nice whole number that I can multiply by itself to get 6, right? And then there's not a nice variable like that I could multiply by itself to get x. So in this case, x minus 6 will also not factor. So once I can say this doesn't factor, this doesn't factor, this doesn't factor, that's when I know I'm finished. So this would be my answer, and that step above it is the work shown. All right, so let's look then at this example, 3x cubed minus 24x squared plus 21x. So I can see that I have a trinomial, and you have to be careful because a lot of people see that trinomial and they think, oh, I need to do AC method. And I probably will have to do AC method, but that's not step number 1. Step number 1 is a GCF. So in this case, I actually have a GCF of 3x. So I'm going to factor that out and then write what's left inside the parentheses. So 3x cubed divided by 3x would be x squared. Negative 24x squared, divide that by 3x, that would give me negative 8x. And then 21x divided by 3x would give me positive 7. All right, so that's one factoring step done, but that doesn't necessarily mean that I'm finished. So I need to check each factor here. Now, 3x, that's a monomial, so it's not going to factor, right? But then x squared minus 8x plus 7, that is a trinomial, so it is likely that that may factor using the AC method. So I'm going to go ahead and go through this using the AC method. So a would technically be 1 because this trinomial, this is technically 1x squared. And then C would be 7. The constant term is 7 here. So AC would be 1 times 7, which is 7. And then the factors of 7 would be either 1 times 7 or negative 1 times negative 7. In this case, I would pick negative 1 and negative 7 because that would add to give me the middle term of negative 8. So I'm going to rewrite my polynomial, but instead of writing minus 8x, I'm going to write it as these two numbers, as minus 1x minus 7x, and then I'm just going to bring down the plus 7. I'm also going to bring down the parentheses. I'm also going to bring down the 3x, right? Anything that doesn't factor, we just bring it along, right? So this is just my first step in any AC method problem, is to rewrite to have 4 terms. And now I'm going to use grouping. So I should have 2 more steps here. So I'm going to group the first 2 terms together. I can factor out an x, which is going to leave me with x minus 1. I'm going to bring this sign down. So in this case, I'm going to bring down a minus sign. And then the GCF in the second group here is going to be, since I brought down the minus, it's going to be negative 7. So negative 7x divided by negative 7 would be positive x. 7 divided by negative 7 would be negative 1. But then bring the rest down. So this whole thing is still in this parentheses that I originally had, and then the 3x needs to be brought down too. So one more thing to write down and I should have my answer. So they had the x minus 1 in common. So I'm just finishing up my grouping step. When I factor out that x minus 1, it leaves me with these pieces. So that would be x minus 7. And then I don't necessarily have to keep the parentheses here since I already have parentheses around everything, but I do need to bring down the 3x. So again, that 3x, that's just the kid brother. We have to bring him, right? We can't get out of it. We try to ignore it and not do anything with it, but we need to bring it along. So each step, we just brought that down. And then let's check and make sure that nothing factors again, right? Until I can say it doesn't factor on every piece, I'm not done. So 3x, that's a monomial, so it doesn't factor. This x minus 1 is a binomial. And so I'll check and see, is it a difference of squares? It is a difference, but that is not x squared, right? If it were x squared minus 1, then it would be a difference of squares. This one is not, so that doesn't factor. And then x minus 7, same thing. It's a difference, but those aren't squares, so that one doesn't factor. So since I can say each of those 3 pieces does not factor, that's how I know I'm finished, and this is my answer. We can always go back and multiply that out, use the distributive property, and check that we get back to what we started with.